going to do a second example here for hypothesis testing. In this case, we'll use the t-distribution. What I'm using is the data from the benzene example on page 351 of the text. I've already entered the data, so you can see it right here. This feels like a cooking show where the person already mixed all the stuff and then shows it to you later. Okay, so here's the benzene example, and according to the problem, the average should have been 1. That would have meant that those stacks were in compliance with the OSHA requirements or whatever requirement. What is the mean here? The mean for the test, and we just take the mean of this happens to be 2.14, which seems like it's pretty high, but we don't know if it's in the noise around the acceptable value or whether it's really means that it's out of compliance. So in order to test it, we're going to do hypothesis testing. The null hypothesis is that the mean is 1. Okay, it means they don't get fined. If we find that we're going to reject that null hypothesis, then this company will get fined. But we're going to look at 3 cases again. Let's look at 3 cases. Let's let alpha be the vector of the 10, 5, and the 1% chance of making a type 1 error. Okay, now I need the standard deviation for the test, and that's just SD of the $sign content. Sometimes in these examples that I'm showing you, I'm putting some overkill in here, but that's just to reinforce all the other commands that you need to be learning up to this point. Okay, so there's the standard deviation right there. What is n? How long is this? I can use length. Okay, that makes sense. And now I've got my mu naught. Let's get the standard deviation that I need, because now we can leave it like this. Alright, for the t-distribution, we cannot just give it a new standard deviation and new mean like we did for the normal distribution. It all has to be referenced with respect to the standard, which is mean of 0, standard deviation of 1. So we're going to have to take the test mean, and we're going to have to put it into a t-value. So the t for the test will be, take the mean for the test minus mu 0 divided by the standard deviation for the test over the square root, lowercase, of n. And now that's my t-value. Okay, I need to find the t critical values. So the critical values, I'm going to use qt, and I'm going to get I'll get a vector of them because I have a vector of alpha value. So here's the alpha. Because it's t, I have to specify the degrees of freedom. So the degrees of freedom are always for t n minus 1. And it looks like this is a right tail test, so I want lower tail equal to false. Okay, so what do I get out? Here are my critical values, and what was my t-test value? Well, from this it looks like that t-test value is more extreme than any of the critical values, so the null hypothesis would be rejected. But I want to go ahead and plot this because I think that's, let's practice plotting things, plus it makes it, you know, graphs are like a killer word, right? Okay, so I need some z values. Pretty, and I'll go from, so I've got 100 intervals along x, or the z-axis. Now I need the y values, and I want to draw the t distribution, so I use dt, and it'll be along those x values, and again I have to specify the degrees of freedom as n minus 1, or I could put 19 either way. Okay, and let's plot that. So I'm plotting x versus y, and I want the type to be a line. Okay. And let's see, okay, there we go. Okay, let's draw some lines on this corresponding to those critical values and the test value. So what I use is AB line. It's a vertical line, and I specify where it's going to be. Critical value 1, and all I want is the number of it, so I just go like that. And let's give it a color. Whoops. Okay. Now this is a good opportunity to reuse the command. I want it to be blue, and I want the second one for the 5% chance of making a type 1 error. And now let's make this one green. Okay, and this will be the third one. And now let's put on there the test value itself in another color, use black, and this will be, oops, the t of the test value. And let's see what we got graphically. Okay, if we had areas under these curves, they of course would be in here, but it'd be so overlapping that that's why I'm using the lines. Okay, the test value is out here in black. So here's the test right here. And the green one is a 1% chance of making a type 1 error if this is 5%, and this is 10%. And as you can see, in this case, for all these cases, the test value is more extreme, therefore the null hypothesis is rejected. Remember the difference between using the norm and the t-distribution. The t-distribution requires degrees of freedom, and also the t-distribution requires that everything be normalized to a mean of 0. The normal distribution, on the other hand, does not require degrees of freedom, and you can give it the standard deviation and the mean associated with the population, right, and it will do those calculations itself. And you can compare things in real units instead of translating them to the standard units.